Integration with substitutions. What we're really learning to do today is back up the chain rule. And the chain rule was incredibly important when we took derivatives. So it's going to be incredibly important when we do integration. So this rule, make sure you understand it. All right, we're going to start with a fairly complicated looking integral. If that x cubed was not there, you might recognize this as a chain rule, something raised to an exponent. We usually did that derivative with respect to what was in brackets, and that's what we're going to let u equal. Whatever you take the derivative with respect to, and that's what was in brackets. So let's let u equal 5x to the 4 minus 2. What does that do for us? Instead of having 5x to the 4 minus 2 to the 10, we have u to the 10, and it already looks more simple. Now, caution. You cannot integrate u with respect to x. All of these x's have to become u's. So how do we get a dx? If you took a derivative, the derivative of u with respect to x, there's our dx. So all we're doing is we're taking our expression for u, taking the derivative of both sides. Derivative of u is du dx. Derivative of 5x to the 4 is 20x cubed. Derivative of minus 2 is 0. Now, this is an equation. Put the dx on the other side. What we're trying to find an expression for is x cubed dx. There's an x cubed dx. If we just got rid of the 20, we'd know exactly what to put in place of x cubed dx. But we divided both sides by 20, so x cubed dx gets replaced with 1 over 20 du. Now, why are we writing it this way? If we write it in the form number, variable, exponent, and we know what we're integrating with respect to, then we can just do the integral. So that's why I took the 1 over 20 du and put the 1 over 20 in front and the du in the back. Okay, before we do the integral, let's go over this again. Complicated integral. We're reversing the chain rule. The chain rule, when you have an exponent, is done with respect to what's in brackets. That's what you let u equal. So u goes in for what was in brackets. We need to have everything in terms of u. So this x cubed dx needs to get replaced. How to figure out what it equals? You take the derivative of both sides of this equation. Derivative of u, derivative of 5x to the 4 minus 2. Put the dx over here, and then rearrange this so that we know what to put in place of the x's on this in this integral. So the x cubed dx, there's an x cubed dx, so just divide by 20, and we know exactly what to put in place of x cubed dx. Now it's in the form number, variable, exponent. Raise the power and divide by the new power, and then clean it up. Instead of u, we have 5x to the 4 minus 2, and instead of 20 times 11, that's 220. If you're unconvinced, take the derivative. The derivative, bring down the 11, leave the bracket alone, lower the power to 10. And then multiply by the derivative of what's inside, 20x cubed. And the numbers would be an 11 and a 20. That would eliminate the 220, and you'd get exactly what you started with. Let's try another. Pretend the 4x wasn't there. You'd have the square root of x squared minus 1. If you were taking the derivative, you'd take it with respect to x squared minus 1. Again, what's raised to an exponent? Let that equal u. Your expression becomes more simple. Warning, x's and u's, do not have those in your final integral, otherwise things will go crazy. So we're going to take the derivative of both sides. The derivative of u with respect to x, and I'm just putting that over there immediately. Derivative of x squared is 2x, derivative minus 1 is 0. Now, we want to eliminate a 4x and a dx. We know that 2x dx is 1 du. What would 4x dx equal? 2 du. We're now in the form number, variable, exponent. Raise the exponent and divide by it. Dividing by 3 over 2 is the same as multiplying by 2 over 3. Let's just check that again to see that we understand what happened. This is a chain rule. If you were going forwards, taking a derivative, you would take it with respect to what's raised to the power. So we let that equal u. There's our u. We take the derivative of u with respect to x is 2x, and then we put the dx over here. If 2x dx is 1 du, what is 4x dx? 2 du. When you've integrated by raising the power and dividing by it, clean it up. 2 times 2 is 4. U is equal to x squared minus 1. And that's your answer. Again, feel free to take the derivative to check it, and you will get exactly what we started with. All right, trig. Doesn't scare us at all. If this was a chain rule, you'd take the derivative with respect to sine. So let u equal sine. Looks better already. We have u's and x's. That's not good, so we'll take the derivative of both sides. Derivative of u and derivative of sine. That's cosine. Oh, this is convenient. Cos x dx is exactly what we were looking for, and that will be replaced with du. And if you're a little suspicious, saying, that was awfully convenient, if it doesn't work out that you cannot replace these x's, you are not allowed to use this method. So it'll turn out that it's always convenient to put these in. All right, variable, exponent, raise the exponent, divide by it, and then u is equal to sine x. If you want to check derivative of sine to the 5x, bring down the 5, that would clean that out. Lower the exponent by 1, there's our sine to the 4th. Multiply by derivative of sine, there's our cos, so it must have worked. Now, on to something different. We're still reversing the chain rule, but we don't really have anything raised to an exponent other than the 5. So we have to think of how we did the chain rule with trig. You took derivatives with respect to angles. So we're going to let u equal the angle. The derivative would be 10x dx. And can you figure out what everything would be here? So I'm skipping some steps now. Sine u, what would x dx be? If you were to get x dx by itself, can you see that it would be 1 over 10 du? So 5x squared minus 1, the angle, was replaced with u. X dx, if you get that by itself, would be 1 over 10 du. Now, be cautious. We're tempted, I think, to get in the habit of raise powers, divide by them, and forget about all the other rules. This is not number, variable, exponent. This is a trig rule. So you have to look at the right-hand side of all the rules and say, what has a derivative of sine? And the answer to that is minus cos. So the 1 over 10 comes down. What has the derivative of sine? Minus cos. Now, why is it minus again? If you have trouble with the minuses, just know it's got to have something to do with cos. When you take the derivative of cos is negative sine. So we have to deal with the fact that this answer is positive. So if we put another negative in, that'll take care of the negative that appears from the derivative of cos. Now, what was u equal to? 5x squared minus 1. So there's our answer. One way to do a little check when you do trig, angles should not change. So that remains constant. And again, you can take the derivative if you want. Derivative of cos is negative sine, and then multiply by the derivative of the angle, which is 10x, and you find that things clean themselves up and give you exactly what you started. Whew, what if we do ease? So when you do trig, it's with respect to angles. When you do ease, it's with respect to exponents. So we're going to let u equal sine x. Derivative is cos x. Ooh, there it is, convenient again. Had to be convenient, because if we can't get rid of the variables, we cannot integrate. When we substitute, what do we get now? E to the u, and cos x dx becomes du. Now, what rule is this? This is not number, variable, exponent. This is an E rule. Derivative of e to the x is e to the x. So integral of e to the x is e to the x. That's a nice one. You're going to like it when you see these. This rule should be an easy one. And then what did u stand for? U stood for sine x. Check it by taking a derivative. Remember the E rules, you write down exactly what you started with, and then derivative of exponent. Seemed to work. Okay, spend lots and lots and lots of time on this today. You need practice. This is the most important integration rule. And then when you're done, more practice. So on page 4, you'll experiment with everything we've learned so far. And so have fun. It does get better the more you do, and if you have questions, let me know.